Hey, what's going on, folks? It's Mike here, and welcome to my deprogramming language quick start. Now, if you're watching this, maybe you're one of my students, maybe you're just learning about the deprogramming language, or you just want to try out a new language, or maybe you're looking for a competitive advantage. And that's what I kind of consider D. It's a really special language in that it's modern and it's got a lot of really cool features, but performance is one of the really important things about it. Now, let me go ahead and just orient us. We're going to kind of get into this and learn about the deprogramming language and just understand how to get started. But the reason I like D is because it's a language highlighted here where you can write fast code, it's easy to read, and again, it's really fast to compile and build code, especially the DMD compiler. So here's an example we'll maybe take a look at here, but first and foremost, you should know about dlang.org. That's the main programming language website. And you can read about it. You can see what companies have used or are currently using the deprogramming language. Again, it's a really awesome community and awesome language. So there's forums, there's a Discord, check those out. And of course, you can find me on YouTube. I've got my playlist here. So usually if you search my name and dlang, there's also the D-Language Foundation for YouTube that has a bunch of talks and resources. So anyways, you can check out a bunch of these things here. So anyways, here's my YouTube, which you already know about because you're watching this. And I've also got my community, that same deprogramming language website. If you want to watch it in a distraction-free environment, feel free to join in there, but you don't have to. Anyways, back to the deprogramming language stuff. So let's just go ahead and first and foremost just like write a program just to go ahead and show you how easy it is. I'm just going to write a like hello world here. Let's go ahead and do it this way. Standard IO, right line, hello world. Okay, so simple enough here. And I can actually just kind of build and compile this with RDMD here. Now, if I want to compile this into an executable, you can do this if you're coming from a C background here and have the compilation and then execute that way. But RDMD are a really easy way to just compile, build, and get started really, really quick. So it's a really nice language and very familiar syntax if you're familiar with C style or C family languages for what we're seeing here. So I'll go ahead and leave the source code up top here so we can kind of understand what's going on. Let's go ahead and just explore the language just a little bit here. As you're exploring, again, you can check out various video tutorials that I have here, but you probably want to look at like the library reference and just see the wealth of things that you have here. So the standard library is called Phobos. And whenever you see something that begins with std, stud, that's part of the standard library. Okay, so just keep an eye on that here. It's got a bunch of useful utilities for, parsing various file formats, doing things with zip files, database stuff, sockets, etc., etc., etc. There's a lot of multitasking stuff. I've been recording videos on that. So anyways, there's a lot of good stuff here in the standard library. It's much larger than the C standard library, and it's probably got a lot more utilities actually than even the C++ library. Although I'd say they're very nice in how they work together. So that's the library, that's the language. We'll look at some of these features here so you can kind of dive into things here. Okay, but we want to just start writing some programs here. So again, if you're coming from a C background, a lot of these things are going to be very familiar, creating variables, creating pointers to variables. I can take the address of that value, for instance, and then I can actually just print these out. X is, and I'll just put it out to X here. And then let's go ahead and do the pointer here. So you can see the address, and we can dereference things. So you've got your low-level facilities like pointers and so on as you need them. And I'm just going to use RDMD here to compile and run that just to show you there. So you can see the address that is stored in there, and then of course dereferencing P, which is pointing to the address of X. So again, we have all those facilities. Okay, great. Now, before we continue our deep dive, though, because you might want to also follow along, and again, I have videos on that. The first videos of the YouTube series is about how do I get the compiler and stuff. You should download a compiler here. So there's actually 3 compilers, and this is something that's interesting about the deprogramming language. DMD is the one that I tend to use. It's the reference compiler. Again, it always has the latest stuff in it. And it compiles really, really fast. That's why a lot of folks like the DMD compiler. So anyways, that's probably the one that you should default to. It's got support for building on like x86 machines, 64-bit machines, and ARM support is coming too if you're on Apple Silicon. But otherwise, you might prefer, or generally what I'd say if you're on a Mac, for instance, to use LDC. That's for you Mac folks. It's LLVM-based compiler, and if you're used to using like GCC, there's GDC, which is the GCC compiler family. So kind of a cool thing about D is that it's here to stay, right? Obviously, there's the reference compiler, but it's been adopted, the front ends, into GDC and LDC. And this gives you all the support that those compilers have, right? You can target tons of platforms from the D programming language. So again, that's kind of an interesting thing about D has this support. So you can kind of follow the download instructions. There's various installers for Mac, Windows. Your package manager can do it. There's also this install script as well. And for the Mac folks, again, you can watch the videos I have here, but just go to the download. And again, there's some script here. Anyways, you could just use that here. There's also tooling here. If you want a language server, code D, I think you can find it if you just search in like VS Code if you prefer that. Again, I'm using Vim, so that's fine with me. I've got videos on powering up your IDE and some of these other things. All right. So anyways, that's just how to get started here. Let's get back into the language here. One of the things I like, again, about D is it kind of looks Pythonic in some ways. If you're a Python programmer, like if you want an array of values here, you just do something like this here. And then maybe I can append an array item. Let's add in 6 here. And then I can just simply write out that array. Okay, so let's go ahead and see the result of that. There you are. I can do other operations on arrays, for instance, like let's create a second array here. This time I'm just going to use auto. I'm just going to call array 2, and D is smart enough to infer the type for you if you've got some like complicated type. And we could just do something like let's just write out, and I'll compute it here, the array, the first one and the second one. I'll just concatenate those together, and then you can see the full thing here. And maybe if I wanted to maybe even just look at part of this one here, I could just look at the 0th to the second element, something like that. So you can do these slices. And slices are just a view into the array. It's not making a copy, but it's just a view into the same array, same memory addresses here that you can look into. So you have these nice sort of like slicing capabilities here that you can do. And maybe I want, let's get the rest of this here. Let's do 3. And I can use $sign for the end of the slice there. So then I can see, oops, let me make this 2 here just so we can print out the full thing here. So anyways, 1, 2, 3, 4, 5, 6, we get the idea here with these slicing operations. So you can do a lot of these nice operations. You can support multiple dimensional arrays and so on here. But that's just a quick look into what's going on there. Now, some other ways to D has for loops, so I could do something like for I equals 0, I less than. Let's look at the array length. So I just have a member function built into that array there, and then I can just write out each of the elements here at I, or index I into that array here. That also works. So you can see those being printed out here. Okay. Now, of course, for each loops are probably even easier. So I could just say for each of the elements in that array, write out the element on a new line here. That's going to do exactly the same thing here. Right? So you're going to see this printed out twice. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 here. Okay. So D does a lot of stuff with ranges, which is really nice. And again, you can kind of combine this with everything we've learned before, play around with it here. Do something like that, and just print out one of the elements here. If I try to pass in something illegal, D does bounds checking by default here. You can turn that off. Again, it's a systems language, so you can get performance, but that'll give you some ideas about the errors that you got. And in this particular case, it's giving me a stack trace. It's missing the information here. That's why you see the question mark. So -G puts in your debugging symbols, just like your other compilers will. So now I can see at least here in the main function, the code that I own here, what's going on here. You'll notice the actual start to the program's _d main. So really quick, again, let's actually compile this now. I can use dmd here, -g, this file here, and I can explicitly set the output file to prog, or if you're on Windows, maybe do like prog.exe, something like that. But this will do the trick here. Then if I run this in GDB or choose your favorite debugger, again, I've got a bunch of resources on debuggers here, but let's just go ahead and launch this. You'll find this symbol here, dmain, And if I just do start, that'll put a break on the D main here. Okay, and then you can go next and sort of, step debug this program here, right? Just like you normally would. Again, I've got some full videos in my playlist on how to use the debugger when you run into trouble here. So you might want to do stuff like, again, like print out the arrays and stuff. So how do we do that? Well, I need to print the array pointer. That's one of the properties, or print the array. I could print out like a p array. Let's see here. I want to do yeah, let me remember here. So I needed to hit next here just to move along here. Let me do that a few times here. And then I can print out the array at the pointer here. Let's see if I might have needed to wrap this in parentheses here. Array.pointer. So I get the address and then dereference it. And then get the elements there. So that'll work there. So I had to pause the video for a moment. So anyways, you can watch my full video on how to do some of the debugging there with pointers and so on. So anyways, you get all those capabilities as usual here. Okay, let's see here. Let's actually do some other things that could be interesting. Let's go ahead and I'm going to go ahead and just comment out this here, most of this. And let's just go ahead and let's paste it in a new block here. I'll call this like the hello into the deprogramming language, right? We know about arrays, for loops, and so on. And as you can see, we're now writing our own little function here, right? A different scope here. Okay, great. So we've got this separate scope here. Let me see if I have my, oops, I don't have my fold method here. Set fold method to manual. Let's hide this just for a moment here. That's our hello world. Let's actually talk about function calls, right? They can have some function foo here, and it can take in some parameter like hello. Let's actually take in an array here, numbers, something like that, just so we can see how this works here. And let's just call this times here. And basically what I'll do here is I'll say for each of our elements in numbers, let's just write out the element times, well, whatever value you want to multiply them by. Okay. So anyways, we make our regular function call by doing 10 times, and then I can just pass in an array like this. Let's go ahead and run this and see what happens here. I think this will do the trick here. Oops, it says no return value, right? I say I'm returning a value here. So I could return some integer value here, 42, or something that is of int type here. Let's actually just make this void, okay? And then I can, I can just add a empty return statement, or it's fine without it. Let's go ahead and just do that here. There we go. So 10, 20, 30, right? I'm multiplying each of these values by 10 here. So that's how function call works here. Now, again, when I'm passing in an array here, if you're coming from C languages, this might give you some red flags because you're like, hey, how do I know what the length is here in this for each loop, right? Because I have to be able to iterate through each of the different elements. Well, you kind of saw me do this in the previous debugging session here, where arrays, right, which in languages like C and C++ decay to pointers, that's not true. And in D, you can think of arrays as a pointer and a length. So recall, we have a pointer and a length with the arrays in D. Okay, so sometimes they call it fat pointers, but that way we know exactly the length when we pass it into a function, and that's super, super convenient here. Now what would happen here if I said here numbers at 0 equals 7? Okay, so I'm passing in this thing that has a pointer to it into a function here. And let's go ahead and just write out, maybe we'll just go ahead and store this result then, auto values equals 1, 2, 3. And then I can just pass in values there. That's an array type. Let's actually look at values at index 0, right? Because I'm calling this function that is changing, right? So I call foo, I pass it in here, and then somewhere I change that value. Now remember, since an array is a pointer and a length here, I should be actually then changing that value here, right? So I get 7 as the 0th index here, right? So again, in D, just be aware that I am passing in an array, which is a pointer and a length, and it's still a copy of that pointer and length that's being copied, but the actual address that it's pointing to is being changed here. Okay, so it's still passed by value. Now, if you wanted to pass by reference, you could simply add in the reference keyword. That's not really going to change this example that much here, but I just wanted to, again, show you that in our crash course. Okay, so that's just a little bit about functions here. Let's go ahead and kind of comment out some of this here. And then we'll do a recap here, but again, this is just our little crash course. The other thing I want to show you, let's go ahead and do a little task here. Make the screen a little bit larger here. Let's go ahead and say, let's create a data file here. Data.txt, something like that here. And I don't know, let's do something like student names and information. Joe, let's give you a different, value here. And I don't know, who would be somebody else? Walter, the creator of D. I don't know, 42, something like that here. Okay, so let's talk about something that we're going to be doing, like opening and closing files. Again, parsing data. So if I want, I can open a file here, something like this here. And I want to read in the data.txt file, and I want to open it for reading. Okay, let's see how far that gets us here. Let's go say, okay, oops, I missed a quotation mark here. The D error messages are pretty good too, so hopefully you're observing that in our quick start. So anyways, we've opened this file. We don't have to actually close it. It's within this scope here. It'll close itself automatically. But again, if you're coming from Python or it makes you feel more comfortable, you can close it as soon as you're done with it. Sometimes that is nice to do. But what we probably want to do here is read in all these lines here. So for each line here, I could do F by line. And let's just write out the line here. Okay. And then there we are. We have our file here. And then, maybe what you'd want to do here, this is kind of something common, is you'd want to say, well, let's not just write the lines, but let's actually append them into this array of strings here. So then maybe I can, process data down here, process data. And then I can actually just write out all those lines here. Okay, now we stumbled upon an error here, which is insightful. It says error cannot append type char with array here, the brackets here, to type string and then the brackets. So a few things here, just a few little nuanced things. If I specify something like this, that's for strings. Okay, if I have the type here, but this is dynamic, right? That's why there's no size specified here. That's okay. But what's the error that we're getting here? Well, I'm reading this file by line. And again, that's just sort of a D idiom. And again, we can find that probably if I go to the library, and we are in standard IO today. So let's go ahead and take a look here. Let's see if I can just search by line and find an example. Usually you can find a nice example like this. Maybe we'll actually open that up in a moment here. Okay. So anyways, what's this error though? Well, when it's reading these lines here, again, what is a string? Well, it's a array of characters, right? That's how we would implement this if we built this ourselves. On D, string types are arrays of characters, but they're immutable. Okay, so it actually looks something like this, where string is an alias for basically an immutable character array, something like that here. Let me get my parentheses right here. Okay, so it means we can't change the strings here. So how do I append then these character type to strings? You either make a duplicate. Let me see if just dupe will make the copy here. That'll work. Or if I want it to still be immutable, idupe for immutable duplicate here. Okay, and that's most likely what we want to do here. And then we get our array of strings. Okay, cool. So we probably want to do some data processing though on these lines here. So instead of just writing them out into the array, which again, D has nice, basically templated functions for writing out the lines here. What we could do is we could say something like, we could maybe split them based off of the space here. So let's go ahead and do that here. So let's kind of break this into like tokens here. And I'm going to go ahead and say this is for lines, we'll split, and let's try something like this here. Well, let's write out the tokens. Okay, once again, no property split here, and it's giving us a little bit of help. Perhaps import standard array. Now I can go into my imports here, and I can do something like this. Let's see if that does the trick here. Again, we're running into that same error here. Or what I really wanted to show you is I can actually import locally as well. So it's just scoped within this main. Okay, so that's just another thing that might be new for you. Let's see here. So again, I want these lines that I'm splitting here. Let's see here. So a few different thoughts here. So you cannot implicitly convert, right? Because when we wrote this out, let's go to our let's go to our history here. Let's just actually write out lines. Okay, something like this here. We've got a array of strings, and so that's what it's complaining about. We can't just, how do I split this, right, and treat these as separate entities? So we got a few different choices here for what we can do. We can either, let's see if I do join here and then split. Let's see if that'll help us out here. That's one way that we can do this, right? We could just take all the lines here and then join them. And I'm doing something that's kind of neat here. Let me see if I can even remember how to do the equivalent here. Where in most languages, we'd have to do split, join, and then lines, something like this here. And then, let's see here. I've got to make sure I split. Okay, I think the parameter is something like that. Yeah, I think it's going to be something like that here. All right, this is kind of nasty to write out a line here. So in D, we do something known as uniform function call syntax, UFCS, you'll hear it. Again, there's videos on it, where you can basically say, well, if this is the first parameter, I can actually just move it to the left and then do the dot operator. And then I can specify any other arguments within as I need. And this allows you to just write things left to right. So if you're coming from like JavaScript or something, this will be familiar. But hopefully, you know, we should write our code like this here, okay? So prefer uniform function call syntax here. Okay, that's what this is here. So that's another big feature of D that you'll see here. Now you'll notice here when I did the join though, this didn't quite do probably what we wanted when I wrote the tokens, because right, there was no space after here. So I think when I do the join, let's see here, I can pass in on split, I can split on spaces, or let's see if I just do another split here on new lines here. So can we just combine here? No, I got to remember how to pass in an array of delimiters. I mean, we could sort of do this in multiple steps here. Let me see if this will work here. If I can split on new lines or spaces. Oops, we don't want to go into GDB. Moved about it too fast there. Yeah, that's getting a little bit more interesting. It still just gave us one string here. So yeah, I don't know if I want that. Let's go ahead and see what other operations we've got here in our standard library in our quick start. Probably what I want to do here is go into the library here. We were in array, so we can see the array operations. And we can see some of these things like joining, splitting. Let's go ahead and see what's in split here. Let's see, we could provide the separators here. Yeah, we can do like split on white space. And I think on join then, we can also concatenate. And then let's see, I think we can also add in a like comma or something when we do that join here. So a few different ways we can approach this. Let's just keep our split simple here. Let's just use the single character here. And when we join, let's see if we join with a space, if that will do the trick here. Yeah, that'll do the trick. That'll give us each of these individual tokens here. Okay, we end up with this weird like white space token though, because we got Mike, the ID, Joe. Oops, I put in an extra space here. So what are some other things that we can do here? Let me see if I've got in the standard library here. I think we probably want either, well, we can either do a few things here. We can either filter out the tokens that are empty, or we could go into like a foreach loop or something and sort of handle things. What I'm going to go ahead and show you is, I think we just do remove, and let's just remove empty strings here. There's also a unique here. Let's see here. Let's just do this in a second step here. Let's just actually say tokens equal tokens.remove, and I think we just can remove like that here. Let's see if that does the trick here. And I think remove actually just wants to remove an index. Yes, no property for these types here. So again, let's just do the easy thing here. Look for dlang filter. And basically we could just chain in the filter. And this will show something I think new and interesting about the deprogramming language here that I think is worth having. Yeah, let's not do the remove. Let's do here. And I could do this in the same line here. I am going to need to include stud algorithm. You can see this is under the stud algorithm there. Filter, and then if I put the exclamation mark, that's a template here. And the type of template that it wants here is for each of the elements here, I basically want to say a not equal to an empty space. Okay. So let me make this a little bit bigger here so you can see here. That's the filter that I'm passing on here. So it's going to keep everything that we split there. And I think we're going to need at the very least to include algorithm. And I think we've already got array here. I think this is going to still cause us yet one more problem here. But let's just go ahead and try to compile it. And then I'll explain the problem here. That's why we're just doing this kind of live here. Let's see here. It's going to say, oh, maybe it doesn't like this extra semicolon here. Yeah, because I think we can get away with just this test here. Okay, so cannot implicitly convert filter split of type. This, I mean, so what's the type of this expression that we've chained together here? Well, it's the very last thing that this returns, right? Because we're just working left to right. We've got a string, we join them, we split them, etc. You'll notice that it's this weird like filter result. And this confused me for a long time in the D language. That's why we're just doing this live coding so you can see what's going on. But basically I just want to convert this to an array. Okay, so that's the last thing that I'll chain there at the very end here. And then now, let's see here. Oops, I guess, well, we can make this. We just want to filter out empty strings here. Okay, in case we make any errors. So anyways, that's just some of the stuff you can do with data processing here. Okay, now I'm going to go ahead and show you two more things, two more topics rather. That says, great, we've got this in this form, but really what we want or we might observe is that these are pairs here. And you might have actually caught these in some of the array operations where probably I just wanted to iterate through these by line, break up each line, and then I can have a key and then a value. That's what this is, a key and value pair. So let's just go ahead and now create a map here. The key is going to be a string. That's what I'll look up here, and the ID is going to be int here. So I'm just going to go ahead and put this as the key value pair. And just to illustrate this, this is the key, this is the value. Okay, let's kind of see how that lines up here. So I don't know, we could call this like students or something. And then maybe what we'll do here is, now that we have our tokens, since it's every other one here, let's just iterate through these two at a time here. A few different ways we could do this. Let's just do this in a for loop to start here. Well, I is less than tokens.length, I plus equals 2. And what we'll just go ahead and do here is say students with tokens at I. So let's see, the key is going to be the first thing. Will just be equal to tokens at I plus 1. Okay. Now we're going to run into another problem here. Don't worry though. Let's see if you can see what the problem is. So this cannot implicitly again convert type here. This here, right? We have an array of strings which matches our key. Our value here, which is a string, we don't, right? So we need to do to int, whatever our type is. Okay, we're going to need to include a library here. Let's see if D helps us. It says, hey, I don't know about this here, so import the std conversion library here. Instead, sometimes these get a little bit ugly to put these all in one line here. So if they're all in the standard library, I like to just do something like this here and put them all on one line. Okay. Now you can do other fancy like named imports and renaming of things as well. But that'll do the trick here. Okay, so we've run this here. We've got students. Let's just actually write out students as such here. And then we can see our key value array here. The key colon value. Key as a string, colon, integer as the value. Okay, so simple enough there. And eventually, you might want to do something like this here. So I can iterate through the key value pairs. And let's just write out the key, comma, something like this. So maybe I want to, just format this a little bit differently for whatever reason here. So let's comment out that version. And oops, let's see here. What do we get here? For this template here, if it reads the first parameter as this string here. Oh, actually, maybe this is a values. That was just a typo here. Let's just see if this actually builds. There we go. Yeah, okay. So Joe, Mike, Walter, etc. Right? So that's how we can iterate through our key value pairs. If you want just like the keys, you have like by keys, and I think it's by values. So there's a few different ways to kind of iterate with the for each loop here. And then of course, these are unordered maps, or unordered associative arrays, as they call them. You might have learned these as dictionaries and other programming languages, but that's the basic idea. Okay. All right. Last topic that I want to cover is data types. So structs here. So maybe you want to create a struct as a student, and I can create this locally within a function, or most of the time what you're going to be doing is, something like this here, right? Outside of the main, you'll have a type here. So no semicolon at the end or anything. And let's go ahead and put the name and the ID, something like that here. Okay. Now structs are value types. Structs are value types. And if you have a class, that's a reference type. Okay. So that's the other way to create your own user-defined type here. So we can create a class, student class here. And the difference is that with classes, again, you have to watch the full video. Classes are reference types. But the basic summary is we have to allocate these on the heap with new by default. Okay, there's other ways that you can allocate with malloc a class, or even you can put it on the stack, but that's just sort of the default. And structs are value types by default, meaning you can just instantiate them. Okay, so let's go into our little example here. And what I might want to do here now is create an array of my students here. And I'll create my student. Let's just actually create a new student. Temp here equals student, and then the key and the value. Okay. Now you'll notice here for this struct type here, let's go ahead and just split this, go to the top. I constructed it here, but I didn't provide a explicit constructor. Okay. If I wanted to, I could provide a constructor that says I need to provide the string and then the ID. I can't use a keyword, so something different here. So the name, something like that here. And then I could do mname equals the name, or again, if you want to be explicit, this referring to the instance of this object here, but this is also okay. MID equals ID. You could also do that. But in D, you don't have to if you have a simple struct like this. It's called a struct literal to just basically construct this student here in the order that the fields are listed in the struct. Okay, so simple enough. Okay, and then I can provide member functions for things like print, hang out the student here, which I'm just going to do as student colon, let's just do student info or something, and name, comma, something like that here. Okay, so let's collect our students here in my students. And again, it's just a regular array. You can store any data type here. And let's just append those here. And then let's write out my students. Okay, so here we are. Same thing. We've collected our key value pairs, and then we created a struct from it. And then we have our students here. And we can process these, we can sort these, we can do all sorts of other tasks on these. So anyways, I think this gives us hopefully a quick enough start into some of the different things in the D programming language. You can kind of code along here. Just spend like 30 minutes or so trying this. The thing I want to revisit is where we started from here on the homepage about why D is also cool in modern language here. I mean, it's got all the concurrency stuff in it that I think every modern language has. It's got things like fibers, which are its version of coroutines. All that stuff you saw me doing with like foreach loops and ranges are super, super nice. But the other real superpower of D is its ability to do stuff at compile time. So for instance, I'll just run this snippet here on the web page here. It sorts all of this input here. Let's go back to the code here. That's read in at compile time. I think there's another example of like sorting an array here at compile time. Let's see if it's just this one. I might need to refresh the page here to get that example. Let's see here. Sort lines, sort an array. Yeah, something like this here. So this will kind of demonstrate that D at compile time can sort basically and store the result of whatever this value is. And this value here doesn't get stored at all at runtime. So you don't pay for the cost of computation. So you can kind of study this example. Some of my other talks, I talked a little bit more about it. But this is basically just going to print the message during compilation, so before you run the program. And I'll go ahead and maybe just like leave us with this one here, just so we can fully understand it. So let's exit these samples here. And let's just go ahead and I'll make an example called sort. Let's paste it in here. And again, I'm just going to compile sort here. Let's see here. Oops, what did I do here? I forgot to include the, actually, a little bit of a snafu here. Let's call this not sort here. I think it's getting confused. Let's call this sort 2. There we go. So what's interesting about this, and I'll explain that sort thing. I'm glad I made some typos here. We learn a lot more from those, but anyways, again, I've just compiled this. I haven't even run the program, right? If I want to run the program, I have to run sort 2, and then I'll just say printing program. So, I mean, really stare at this for a moment. That's pretty cool. Like, we're able to sort and store a result when we compile it as a developer. But then as a user, when you actually run the program, this data is already sorted, right? And it's already, if I want to access this, I can access this through the variable b here. Go ahead and write line. B is, something like this here. So again, let's compile it. Let's run it. And then we can actually see what B is here. Now, if you're like, well, this is okay, a sorted range, this ugly thing. Again, we can use the trick where we do b.array to convert it to an array and then do something. The reason you get this sort of long type here is because it's part of supporting that chaining together ranges. So anyways, that's the idea here. So anyways, I think this is super cool that at compile time you can take out a lot of the computation and save your users time. So that's neat. Now, why did we run into this error where I called this sort? And I had the same, like, we call D, each D file is a module. And then if I have the module name be sort and the function name sort, it doesn't like that, right? There's like some naming collision there. So you'll notice too in D, we never specified like header files or, there is a way to have separate interface files, .di files, D interface files, but typically you don't need those. You have a module here. You can compile stuff in whatever order you want. I can define a function like foo down here, and then I can call it up here. Compile is super fast. You don't have to worry about the order of things. So again, these are just nice features of a modern language, a modern compiler, that they build really fast and you have a lot more flexibility. And the language just honestly looks nice, right? D has taken a lot of effort to get the right defaults, things like integers, for instance. will always have a default value of 0. Floats have a default value of nan, not a number, right? So you should always, initialize them. Just keep that in mind. But those are a few of the other things that I copy or cover in my D series. So you can kind of, watch one of those videos per day as you're learning the language if you really want to dive in. So anyways, folks, this is a little bit of live coding here. Here's the fun example that we did here. Let's go ahead and just show again. We learned about how to do some of the basics, what arrays are, some fun operations we can. It kind of looks like Python. And again, arrays are lengths and pointer values. We have function calls. We need to keep track of if we're passing things in. We're passing things by value by default with value types. So things like structs, for instance. Classes are reference types, so you will be able to modify those within functions. But anyways, keep track of what's going on here. And again, we don't have to worry about a lot of these things in older languages like C, where you have arrays, decay, and pointers, because we know the pointer, we know the length, and so on. So we can mutate the data as well. If you don't want to mutate the data, again, think about making things const or immutable and so on. And of course, we learned about specifying our own data type, which we used in this example down here, where we learned how to open a file, iterate through it, copy the data in an array, some processing of data using uniform function call syntax. And then we just did some data processing here to process our results and put them into a in-memory key value data structure, which we call associative arrays in D. All right, folks. So anyways, that was 40 minutes or so of hacking. Again, I'll leave you with the D resources here. Choose whatever suits your needs. It helps you learn the language here. A lot of great resources, great community, and it's language that I enjoy using. So hopefully you'll find that the same. Feel free to ask questions in the comments or in the forums. And yeah, we'll look forward to seeing you in any of the other videos, or if you're in class, I'll see you in class. Anyways, folks, have a good one and see you in the next one.